and welcome to another SLP at UCLA video. Today we'll be talking about the basic mates you'll see in the assembly window of SOLIDWORKS. So the first part, or the first step, is to open a new assembly, right? So this is just File, New, and then instead of clicking on Part, we're going to click on Assembly here. And this will take us to a new window, and it'll say Begin Assembly over here. And what we want to do is we want to import some new parts to use in the assembly, right? So I have a cylinder open, but I want to use this rectangle that I made earlier. And I'm not clicking anything, it's just going where my mouse is. So whenever I click, it'll place it down. And now I can move around my mouse and it won't move around the box. So you can see over here that it's fixed, F for fixed. So what we can do, and what we usually like to do, is go over here and tell it to float. That means I can drag it around, right? This is me dragging it around, not it following the mouse again. But it's able to move around. And now I can go in and start mating this to the origin. So we're going to click this paperclip icon, which is this labeled mate. And here are the standard mates, right? We're going to go over these today. So what I'm going to do with this is I'm going to do a coincident mate, right? And I'm going to come down to the front plane of the overall assembly. And the front plane, we drop down this, of the rectangle test block. You can see that now they're going to be coincident. So the front plane and the front plane are coincident. And I can click the green check mark. And then we can do the same thing with the top plane. The same thing with the right plane. And now, if we click the check mark again, you can see I can't move this around anymore. But there's no F next to it, so it's not fixed. So next, let's talk about some other different kinds of mates. So if we import another rectangle, you'll see it's the same thing as before, where it's like following my mouse. So I can place it down. And now let's say I want these two blocks to be on top of each other, right? Exactly touching. I would use the coincident mate again, right? You can see now, wherever I drag it, it's always going to be exactly touching the block. It's kind of hard to see in 3D, but you can see wherever I drag it, it's always these two faces, this one and this one, are always going to be touching. Right. Okay, but like, what if I want these guys to be exactly on top of each other, right? I don't want to like have to drag it around, right? So what I can do is I can mate this side to this side, which means that those two sides will always be next to each other, right? So now it can slide, but it can't go back and forth, just go this way, right? If you ever select something you don't want selected, like I've done right now, just come over here, right click it, and just delete that, right? Okay, but going back to getting this exactly on top of each other, click this side and this side, and now can't move it around at all, right? And that's because this bottom one is fixed to the origin, like we did the first step, and this one is fixed to this one. So now neither of them can move. Okay, so let's insert another rectangle. So now let's take a look at the parallel thing. So let's say I want this face to always be parallel with this face. So now it'll move so that it's parallel, right? We can put the check mark. I can move it around, but these two faces are always going to be parallel. And then we can do some of the things where, like, maybe we want this face and this face to always be there. And now we can set, now it'll be just a slidey thing up and down, back and forth. We can't move it. to the left or right. It's kind of hard to see because 3D makes it difficult to show this, but you can't move it to the right or left. So let's insert another component. It's another rectangle. We're gonna have a lot of rectangles today. And now let's look at another thing. Let's do perpendicular. Right, so we can say this face and this face are perpendicular. And you can see nothing happens. And why is that? Well, it's because this face and this face are already perpendicular. Well, let's say I delete that that mate. You can come here, you see the mates that you've just created. Right, so if I close this and press mates again, it won't show up. But what I can do is I can come to this drop-down menu and it'll show me all the mates I've done. So I can delete this perpendicular mate. It's going to pop up. Do you really want to do this? Yes, you really want to do this. So what we can do now is we can mate it's perpendicular this and this face, and now they're perpendicular. So it's kind of difficult to get perpendicular to work really well. But we can also make these two faces parallel and these two faces parallel. And then you have this face and this face are more perpendicular than you might have seen initially. All right, getting a little cluttered now, but we only have 2 more really to go. So let's close this and let's insert a new component. We're going to insert our cylinder. So I made the cylinder earlier. And what we're going to do is we're going to mate this cylinder tangential to a different face. So we're going to say the outside face here is there, and you can see that SolidWorks knows usually what you're trying to do. So it knew that I was trying to do tangent. So you can come here, you can see that these two faces are tangent. So I can drag this along, but those two faces will be touching this, kind of like the coincident one, right? But this is for circular faces. And we can see that if we import another cylinder, we can make those two also tangent, right? So now this guy can rotate around the first cylinder. Right. So now I didn't quite prepare this one in advance, but I'm going to make a new part in here. And you can do this in assemblies, but actually I think I won't do that in here. I'm going to make a new part. And it's just going to be a little donut shape. So we can make a donut shape. So let's share this is about 70. This can be. I know that the diameter of my cylinder is 40, so I want this to be a bit bigger, so we can say 60. So now we have that. We extrude this, let's say 100. And now I have that. We can save it as donut test. And now, since I have this one open, I can go back into SolidWorks, or back into the assembly. And I can go to the assembly tab up here, and insert components, and anything open will be here, right, under the open documents. But, right, so donut test is open, cylinder test is open, but since the rectangle was not an open file, I had to go searching for it in the folders of my my computers. So that's something to keep in mind when you're making stuff. So try to put things in the right folders. Right, so let's open up our donut test. And our last mate today, it's going to be the concentric mate. So we can say like this circle and this circle are concentric. And concentric just means like kind of like parallel for circles, where the center of like the axis of both circles is the same of both cylinders. So you can see that this thing can move out and in, but stays in the same place on this axis, right? And then I guess there's really one more mate that we can look at, which is the lock mate. We don't usually use this, but we can lock like that in place. That and that. So now those two move together. If I had done, let's delete that one that I just did, but if I had done this one and this one, which doesn't move, right? Now you can see this doesn't move anymore. Can't move this around. All right, but locking typically isn't that good because it stops any movement in your assembly that you might want to move later, even if you don't want it to move right now. Okay, and then I'm going to show you one more thing, which is these two things down here. We're going to import another rectangle, let's say. So let's say you have a rectangle and you want it to be exactly 10 millimeters away from this edge, but still like parallel and coincident, like all that stuff. So what you do is you would mate this side and this side, and they're now touching, right? That's what coincident means. But what we can do now is we can click on this little distance thing. It's labeled distance. It's these two parallel lines with some arrows between them, and it'll go back to where it started, basically. And what we can say is like, okay, I want this to be 10 millimeters away. And you can see if we go to this side, it's the wrong way, right? I want it to be on this side. So what I can do is going to flip the dimension. So now it's on this side, right? From here to here, it's going to be 10 millimeters. We can make it a little more obvious by making those coincident. And these guys coincident. And now, these two things are going to be always 10 millimeters apart. And that's what this distance mate is here. The angle one, which you may have seen earlier, let's insert another rectangle. So we can mate. Let's say we want this side to be coincident, but not actually. We want it to be some angle apart. Let's say we want it to be 45 degrees apart. So now 45 degrees, maybe to visualize it a little better. So flip dimension sometimes works, but just there you see it didn't really help us visualize that better. So I'm going to turn that back. I'm going to change the mate alignment, right? And now I can flip the dimension. And that is a little bit more like what I'm trying to show you guys. So do that, and I can say that this coincident, right? So coincident doesn't have to be just faces; it can be edges, points, or anything really. Now you can see that those two are 45 degrees apart. You could say maybe not a coincident. And there you have it. Those are the basic mates that you'll see in SolidWorks. Coincident will be your friend. Tangent and concentric are very helpful for mating screws or something into the right place. If you have any questions, feel free to leave them in the comments. More videos from SLP are down in the description below. I hope you learned something today, and have a great day.